discuss preparation of standard oxalic acid solution. As I have told you earlier, a standard solution is a solution whose concentration is known. So now we are going to prepare M by 50 solution. M by 50 means that 1 by 50 molar oxalic acid. Now what is oxalic acid? You know it is CO2H, CO2H. It is the simplest dicarboxylic acid, and by the way, the IUPAC name of oxalic acid is ethane dioic acid. But in oxalic acid crystals, there are two modes of water also. So oxalic acid crystals are H2C2O4 2H2O. That means its molar mass will be 126 gram per mole. This means that in order to prepare 1 molar solution, that means 1 mole in 1 liter, you need 126 gram per 126 gram per liter. 126 gram per liter is needed to prepare 1 molar solution. So for 1 by 50 molar, you will be needing 126 divided by 50. Now our aim is to prepare, suppose 250 ml, because we will be using this is the standard flask with me. So this is a 250 ml standard flask. So I have to prepare 250 ml of solution, not 1 liter of solution. So how much will we weigh? We will weigh 126 divided by 50 into 250 upon 1000. 126 by 50 is 4000 milliliter. So 1 milliliter is this divided by 1000. So 250 milliliter into 250. So this is the calculation. Now it will amount to 0.63 grams. So if I weigh 0.63 gram of oxalic acid and dissolve in water, making a 250 ml solution, then it is my standard solution. 63 gram of oxalic acid, this is 0.63. Now I am quantitatively transferring it through a funnel. Now I add distilled water. I wash the funnel using distilled water. I am making it to the mark by adding distilled water. When you are doing, you just stop when it is reaching the neck of the flask, because since the area of the neck, volume of the neck is very less, you will cross the mark. So you should not cross the mark. Then afterwards you can fill by using a pipette, as I have already told you. So last 1 ml I am adding using a pipette, dropwise. Now we have to add 1 more drop so that the lower meniscus will touch the line. Now the lower meniscus is touching the line, touching the mark on the, it is touching the mark on the neck of the conical flask. Sorry, now I am pipetting 20 ml of the oxalic acid to the conical flask, which is clean and set there. So 20 ml of oxalic acid. Like this, closing and opening is done with the first finger, not with the thumb. You will hold the pipette only on the tail of the pipette, and the lower meniscus of the solution should touch the marking on the pipette. Now I am transferring this to this washed conical flask. I haven't shown you rinsing of the pipette because it was shown in the previous video. Before the first titration, you have to rinse the pipette and then you have to pipette out. As I had told you in the previous video, the last drop should not be blown out. Just touch the tip of the pipette at the bottom of the conical flask to deliver the last drop. Now my solution is ready. KMnO4 titration, I had told you, it is effective in an acid medium. It is more effective. So you have to add 1 test tube full of 4 normal sulfuric acid to this solution. I will add 1 test tube full of 4 normal sulfuric acid in order to make the solution acidic. I have rinsed the burette with the KMnO4 solution. Then I am filling it with the KMnO4 solution. I should fill the nozzle, just releasing it through the nozzle and filling the nozzle. Now my initial reading is exactly 0. I am clamping the burette. With the stopcock on the right side, near my right hand. Stopcock in a way that is, I will in the right side of me, I will hold it with the left hand. Burner should burn with a non-luminous flame. This is a tripod stand and this is a wire gauze. I will put the wire gauze over the tripod stand. I am putting the wire gauze over the tripod stand and putting the conical flask with the content on the flame. Now you see, this is a borosilicate glass conical flask, so we can heat it, nothing will happen. Ordinary glass conical flask will break if you heat it. So we are using all the glass apparatus we are using for titration they are made out of borosilicate glass. So how long you should heat? The optimum temperature for the titration is around 60 degree, but we won't use a thermometer to measure that. We will just see that some droplets of water is coming over here, or it is a temperature which we can touch. It is not more than that. Don't allow the solution to boil. If the solution gets boiled, then it will be very difficult for you to take it from the flame. So you have to heat it till some water droplets get accumulated near the neck of the conical flask. Now my solution is ready. Now I am taking it for titration. In this titration, the Mn2 plus which is formed, it is functioning as a catalyst for the reaction. So initially the reaction will be slow, and when Mn2 plus is getting accumulated, the reaction will get faster. So you can see that initially the reaction is slow. The pink color is disappearing after some time. Now after some time, the pink color immediately it will disappear because the permanganate ions are consumed by the oxalate ions. You can see the end point is nearing. The end point is nearing. It has acquired a pale pink color. Now I can add one more drop to this. So this is our end point, colorless to permanent pale pink. So this is our end point. Now I have to see the burette reading. By removing the burette from the stand, I will read it. So hold the burette at your eye level, as I have already told you. So my reading is, we will see the upper meniscus in the case of the colored solutions. So the reading is 13.6. So 13.6 ml of KMnO4 is consumed. Now I have to repeat the titration for getting concordant values. So I will repeat the titration.